Hello everyone, welcome to the channel of Algocamp. So now on this particular channel, we are actually releasing a series on data structures and algorithms where we are going to talk about some of the most important data structures and algorithmic topics which are extremely important for your upcoming software engineering interviews. Apart from that, these are some of the I would say topics that are very helpful in your day-to-day engineering job as well. We have already released a couple of series around searching, right? And we got a really good response on that. And from here, we are going to put really some awesome content around DSA. In most of these lectures, we will try to ensure that we focus on the intuition building aspect of the things, that how you are able to think about something, what are some of the things that people actually neglect but are going to clear some of the really important fundamentals. We are going to see coding implementation, but trust me, my focus is not going to be on the language delivery aspect of the things, that okay, you have to code this in C++ or Java. A lot of problems we have coded in multiple languages. Maybe some of the problems will be in C++, some will be only in JavaScript. I believe if you are somebody who is preparing for an interview, language in 2025 should not be a constraint, because most of the people can actually use ChatGPT to do language conversions. So my motive here is to make sure that you understand the concept in depth. You actually see how exactly somebody might have thought about the problem when they were carving out the problem, what can be some initial thought process, how you can actually drive yourself towards the solution. I believe these are going to be some really important videos that will be really helpful for your upcoming career. So do let us know what is your feedback. We are going to release a lot of more topics. Do let us know what all topics you want to have first, right? And the feedback is going to be important. Also, in case you are actually thinking to level up, you want to learn things with respect to low-level design, high-level design, overall system design for interviews, or you are somebody who wants to do project development in Spring Boot, you want to learn advanced Spring Boot concepts, or let's say advanced Node.js concepts, then we have a lot of courses, live courses running on algocamp.io. So you can check out the website courses.algocamp.io/learn, and there are a lot of courses that are actually listed. A lot of great discounts are actually going on all the courses as well. Do check them out. For each and every single course, we are going to add you to a dedicated Discord community where you can get your doubts resolved as well. All of the courses, we have made sure that we talk about things from the very beginner to the very advanced level that is going to help you level up in your career as a software engineer. So that being said, let's start the video without any further delay. So this is a new problem in front of you, one of my favorite problems in Recursion, because the intuition that it gives for actually basic recursion problems that we have already solved. Based on that, what intuition it gives is really amazing. And this is one of those problems using which I am able to prove the fact that you don't need to always like have new problems in mind. Based on the old problems, you can solve ample amount of problems, right? This gives the overall problem solving and algorithmic coding a mathematical nature, right? So the problem says that given n friends, each one can remain single or can be paired up with some other friend. So there are n friends who are there together. For example, A, B, C, D, right? So here n is equals to 4. So there are 4 friends, for example. Now what you can do, each one can remain single. Everyone has a choice that maybe they can remain single or they can be paired up with someone other, right? Each friend can be paired only once. So once you have made a pair, for example, if BC has been paired up, they can't be paired up with something else. Okay. Find out the total number of ways in which friends can remain single or can be paired up. Okay. So if you see this basic test case here for n is equals to 3. So let's try to solve for n is equals to 3. Okay. So there are 3 friends A, B, C. So in how many ways you can either keep some friends single or you can keep or you can prepare pairs of them. So let's see. So if we talk about the first way can be that all of them are single, right? This can be one possible way of the arrangement, right? You have to find the possible arrangements. So one possible way of the arrangement can be all of them remain single. So before we start this particular video, I wanted to actually talk about a very small thing. So this video is going to actually help you understand a real system design interview scenario. We are going to try to mimic a 45 to 60 minute kind of like a round where we are going to solve a problem very similar to how you will solve a similar system design problem in this short time frame. Now, of course, when you work as a software engineer in a company, you have relatively larger amount of time and you can do a lot of more deep dives in even very small level features. But in an interview, the temperament is different, the approach is different, and a similar scenario is actually explained in this particular video. So do consume the content based on that. Also, if you want to see more deep dives and want to understand these topics in a much more deeper level concepts, then do check out the link in the description section below for our System Design 2.0 cohort, where we have talked about a lot more concepts in a lot more detail, which will make you definitely a better software engineer. So let's just start the video. One way. The second way can be AB pairs up, C remains alone. The third way will be A remains alone, BC pairs up. And the fourth way will be AC pairs up and B remains alone. Can I say that? These are the only ways in which you can either make pairs or keep them single, right? So the answer is going to be, so total there are 4 ways. So the answer is 4, right? You can even see all single, 2, 3 paired, 1 is single, 1, 2 paired, 3 single, 1, 3 paired, 2 single, right? And you have to keep this thing in mind that these are combinations, right? You don't need to consider the permutations, that 1 comma 2 and 2 comma 1 are considered same. It's not like AB is a different pair and B is a different pair. No, both of them are same pairs. That's why you have AB as one clubbing and then C. So you have to find in how many ways you can pair some of them, keep some of them single, because everyone has got a choice. Every single element has got a choice that they can be either paired up or they can remain single, right? So everyone has got this choice. So in how many ways, if everyone applies all the possibilities of their choices, in how many different ways you can actually pair them up or keep them single? These total number of ways you have to figure out. So let's take one more example. How about n is equals to 4? A, B, C, D. Okay. So for n is equals to 4, I can say this can be one combination, one more combination, one more combination, one more combination, right? Apart from that, you can have AD paired up, BC remains alone, AD paired up, BC paired up, right? Let's see if anything else is there. So let me write these two here. Okay. Then I believe you can keep BC paired up and AD together. Okay. Then you can keep B separate, A separate, and DC together. Then you can keep B separate. I guess DC you did, DB we didn't do, right? So B separate, A separate, C separate, and then DB can be one possible way, right? And there will be a few more. You can try all possibilities, but the question says that these are the total possibilities that you have to figure out. Right? So given this value of n, you have to just count the possibilities. You just need to count the possibilities. Don't need to do anything else. You just need to do the counting. So how can you do this counting is the actual crux of the problem. So let's see. So first of all, let's try to consider for basic cases. Okay. Let's say if n is equals to 1, that is there is only one friend. So there is only one way. That is, this friend has to go alone. This is fairly simple. N is equals to 2. If there are two friends, then there are two ways. What are the two ways? The two ways are A separate, B separate, and AB together. These are the two ways. For n is equals to 3, though we have already been given that if A, B, C, 3 friends are there, there are total 4 ways. A, B, C, A, B together, C alone, B, C together, A alone, A, C together, B alone. Can I say that? Right. Overall for n is equals to 4. Right. Let's see the total ways. So the total ways are going to be these 4 plus 6. There will be total 10 ways. Let's see how many we wrote here. 4, 5, 6, 7, 8, 9. There will be one more way that you can write, I believe. There will be one more way that should be formed, right? You can figure it out. But there will be total 10 ways for n is equals to 4, right? And so on. So these are the overall possibilities that you can have. Then n is equals to 5, n is equals to 6, and so on and so forth. Now, how can we solve this question? How can we solve this question? We have to solve this question recursively. In recursion, you need a bit of mathematical logic, but not much. Let's think about it. Let's say we were having 3 friends. Okay. Now, I don't know in how many ways these 3 friends can go or these 3 friends can pair, right? Let's take decision on a single friend and try to assume recursively for the remaining, right? So we will try to say that, okay, I'll try to assume things for one friend, that how this one friend is going to go, and try to generalize it recursively for the remaining friends. Okay, so just think about it. If I talk with respect to this C, if I talk with respect to C, one choice that C is having, one choice will be to go single, right? This will be one possible choice, right? That you just go single. Another choice can be for C that second choice can be to go in a pair. Now just think about it. When I say you go in a pair, then situation is not that simple, right? Because if C wants to go in a pair, then there are different choices to make a pair. C can make a pair with B or C can make a pair with A. Can I say that? So if C wants to go in a pair, C also need to consider how many ways are there to make a pair. We also need to consider number of ways to make a pair. Can I say that? Right. So if you are going single, then to it's not a problem. But if you are going in a pair, then you also have to consider in how many ways you can make a pair. So let me talk about it one by one. Case number 1. Case number 1. You want to go single. Now, if you want to go single, then to it is, to be very honest, very simple case. This is a very simple case. For example, if you have A, B, C and C says, I want to go single. If C has decided that C wants to go single, it doesn't matter how AB goes. AB can go in a pair or AB can go single. It doesn't matter. C always goes single. If C decides to go single, then in all the possible ways, AB can go, we can attach C to it. Okay, so let's see in how many possible ways AB can go. AB can, both of them can go alone or both of them can go together. There are only 2 possible ways in which AB can go. Can I say that? If you just see with respect to AB, then there are only 2 possible ways in which AB can go, because C has already made a decision. C is not going to make a pair. C already has made a decision. So can I say that in all the ways AB goes, C goes individually. C goes single. So I can attach C to all of them. So the total number of ways in which AB can go, I will directly attach C to it. Can I say that? Let's take one more example. Let's take one more example. A, B, C, D. Now let's see with respect to D that D says I want to go single. So in how many ways A, B, C can go? A, B, C can go in 4 ways. Right? There are total 4 ways in which A, B, C can go. And because D has decided to go single, I can't do much about it. D always have to go single. So if you want to calculate the number of ways in which the last friend goes single, it is equal to the number of ways in which the remaining friends can make total combination. So number of ways in which nth friend goes single is equal to number of ways the remaining friends go to party. Right? This is going to be one possible combination. When D has decided or the nth friend has decided that he or she wants to go single, in that case you can't do much about it. You have to just calculate all the possibilities of the remaining friend, because remaining friends though still have got choices. No, they can still be single or they can still make pair. So in whatever number of ways the remaining friends can go to party, in all of those ways I will attach the nth friend to go single. So if you have to calculate the number of ways in which the nth friend goes single, nth friend also has two possibilities, single or pair. So here I'm just considering that the nth friend goes single, it is equal to number of ways the remaining friends go to party. So can I say that if I write a relation f of n that gives us total number of ways in which n friends go to party, then can I say one of the component for it is going to be f of n minus 1. What is this f of n minus 1? If nth friend decides to go single, then we just need number of ways for remaining friends. This is going to be one component of your relation that you have to calculate total number of ways. Now some set of ways are going to come when D goes single, right? When D goes single, these are total combination for f of n minus 1. So I wanted to calculate f of 4, right? Now I decided D goes single. When D goes single, the total number of ways is going to be equal to f of 3. This is what? F of 3, right? That is f of n minus 1. Can I say that? So we have deciphered the fact that if one friend goes single, the last friend or the nth friend goes single, in how many ways all of them goes to party. Now the other case is nth friend decides to go in a pair. Now this is interesting. If let's say you have 4 friends and D says I want to go in a pair. Now it's not like D just said I want to go in a pair. Now D also has to tell me different pairs that it can go with. Now D can make a pair with C, D can make a pair with B, D can make a pair with A. Can I say that? Here D can make 3 different pairs. So we need to have all possibilities. Can I say that? Right. So if you consider all the possibilities, one possibility is what? That D makes a pair with A. If D makes a pair with A, you are left with what? BC. You are left with BC. If you have decided that D makes a pair with A, you are left with BC. Now BC can also go in 2 ways. One way is go alone, one way is go together. Can I say that? So if D makes a pair with A, there are total two ways in which all of them can go to party. If D decides to make a pair and decides to make a pair with A, there are two ways in which all of them can go to party. But there is other possibility, P2 also, that D decides to make a pair with B. If D decides to make a pair with B, you are left with AC. Now AC can themselves go alone or go in a pair. So there are two more ways here. Right. So total we got four ways, among which two ways were when D makes a pair with A, then total number of ways to go. D makes a pair with B, total number of ways to go. There is one more possibility, P3, that D makes a pair with C. D makes a pair with C. There are still two ways. So total six ways we got. Total six ways we got. How? Because when D says that D wants to make a pair, D can make a pair with anyone who is remaining, because D has been given the first choice. No, previously also D was given the first choice, that do you want to be single? Yes, I want to be single. In this case, D has been given a choice that do you want to have a pair? Yes, D says I want to have a pair, but with whom? That you also need to tell. So D can have pair with all three of them, because everyone is remaining, right? All of the three elements are there for D to choose from. So D can, if D chooses A, then you will get two different ways. If D chooses B, you get two more different ways. If D chooses C, you get two more different ways. Can I say that? Now, if you carefully see, whenever D makes a choice, D makes a choice, D locks an element or D locks a friend. Can I say that? For example, when D made a choice that I want to go with B, D locked B. So how many elements are remaining? N minus 2 elements are remaining. Can I say that? So I can write, after making a pair, D locks another friend, and we are left with N minus 2 friends. Can I say that? Right. So whenever D makes a choice, then in the total number of ways the remaining N minus 2 friends can go will be the total number of ways with the current choice of D. Can I say that? Let me repeat. When D says I want to go with B, if D locks B, in how many ways everyone can go? The total number of ways will be equal to the total number of ways in which the remaining N minus 2 friends can go to party, because D has made a decision. D has decided whatever are the number of ways, D will be always with B. That leads us to the fact that if you want to calculate number of ways in which nth friend makes a pair, this is going to be equal to what? F of n minus 2 multiplied by number of ways to make a pair. Can I say that? See, in this case, f of n minus 2, that is f of 2, multiplied by number of ways to make a pair, 1, 2, 3. There are 3 ways to make a pair. F of 2 is 2 into 3, 6. And we got total 6 ways, right? So can I say f of n minus 2 represents the number of ways in the remaining friends can go to party, because in each way we have already decided for D or the nth friend. And then this choice is going to be multiplied by the number of ways to make a pair, because with every pair you have n minus 2 friends remaining, right? And how many ways are there to make a pair? Let's see how many choices nth friend gets. So here D gets 3 choices. If there were 3 elements, C gets 2 choices. That C can make a pair with either B or either with A. So can I say that the total number of ways in which nth friend can make a pair is equals to n minus 1? So this is the contribution when nth friends make a pair. This was the contribution when nth friend makes a single choice, plus n minus 1 into f of n minus 2. This is if nth friend makes a pair, right? And why, let me repeat again, why we are having n minus 1. These are the total number of ways in which he can make a pair, he or she can make a pair. And once one pair is decided, you are left with n minus 2 friends. Now their possible rearrangements are going to be attached with your choice. So if you made a choice that I want to go with A, then the total possible arrangements of the remaining n minus 2 elements, you are always going to be with them, right? So 2 plus 2 plus 2 is technically 2 into 3 times, because there were 3 possible ways to make a pair. And with every pair there are two choices, because there are 2 friends only left. That leads us to n minus 1 into f of n minus 2. And this is the recursive relation that you can get. If I talk about the base case, for n is equals to 1, the answer is 1. For n is equals to 2, the answer is 2. This is, we have already established, right? When I wrote some cases here, then we already established this fact. And can I say that this is 90% similar to the Fibonacci relation, that f of n is equals to f of n minus 1 plus n minus 1 into f of n minus 2, with these two being the base cases. And this is how you can solve the questions for the friends pairing problem. Now, if you want to code the same solution, it's going to be a almost same implementation like Fibonacci. You can write int f. It will take a parameter n. So I wrote f of n, right? F of n. My final answer is going to be f of n minus 1 plus n minus 1 into f of n minus 2. If n becomes 1, your answer is 1. If n becomes 2, your answer is 2. So if n is 1 or n is 2, I will return n. Right, because if n was 1, your answer is 1. If n was 2, your answer was 2. So these two can be your base cases. And if you try it here, stdc out, let's say f of 4. If you run it, you can see we are getting 10. That's the correct answer. If you try for f of 3, we should get 4. That's the correct answer. So this is how you can implement the problem of friends pairing.